Hello and welcome everyone, and thank you for joining our today's Geomagic Design X Product Spotlight webinar. This session is highlighting the reverse engineering workflow of scanning and repairing broken parts in Geomagic Design X. And now I will turn the floor to our today's presenter. Let's go!
Hey everyone, thank you for coming out today to our product spotlight again. As we were saying, let's look at some repairing things that are broken. So a couple of things we can do here. So one of the first things I want to show you is something a little involved. We're not going to have time to do something quite as involved as today, but we're going to do a little part that's kind of more fun. So we have a lot of robust alignment tools in Design X, so you can definitely do a lot of scan-to-scan alignment things to get things positioned back where they are. We can put things wherever they need to be based on coordinates and spacing that we already know, so we can actually align to specific sub-coordinate systems if we want to. And then again, one of the greatest benefits of Design X is being able to do this design intent modeling where we can actually modify and change things that we're using for different manufacturing processes. So this is kind of an involved part that we wouldn't have time to do in 20 minutes, but we actually just scanned the whole outside of the part as well as we could get, and got a lot of data on that. And then we went and sectioned this part up. So we went and we wanted to really be able to get the internals of this. So what we did was actually mechanically slice this. So these are all individual slices and then scans of the individual slices. And how we aligned all that back together is we actually referenced all of these slices back to the exterior scan data of the part to get them aligned. We also, we know that essentially the kerf of the slices too. So that's another thing that we can use for verification. So between the deviation analysis on the scans and then the kerf analysis, kerf spacing that we have on the planes in between each other, we can also check to make sure things are lined up where they need to be. So once we did that, we actually went and did a bulk model of the exterior of the part, getting what we can for just some of the base reference geometry on some of these holes and locations and things like that. We went and took those then back and used the interior volumes that we then scanned since it was sectioned, and we're able to use those, to create objects to Boolean out of the rest of the block. So as you can see, this is kind of the outline of the CAD body, finished CAD body, and it is, we have the scan data positioned in there just so you can kind of see what's going on. But then we also have, this is the final part with this data turned on in it of all the stuff that was modeled on the interior. So again, I said it's pretty intense. So let's do something a little bit more fun for today. So what do we have here? We have the broken battery door of the RC car. Okay, everyone's very upset. This thing takes some beatings. You smack some rocks with it, and you bounce it off the curb a couple times, and stuff gets deformed, and inevitably, the little hinge gets broken off. So it's also the same with the remote. I don't know how this always happens on the remotes, but it does. I wish they'd stop putting hinge doors on some of them. But we're going to put this thing back together here. So rather than just slapping a piece of tape over the batteries and hoping they stay there for a while as the thing gets bounced around, let's do a little bit more of a permanent solution. So head into Design X. Let's head into Design X, and we will check this thing out. So you can see there's a good amount of deformation in the part. Things are kind of pushed around all over the place, and then I have the scan of my broken hinge. So let's put this thing back where it needs to go. And again, none of this is on a coordinate system, so it's not on my world coordinate system where I'd want to model it anyway. So we'll worry about that in a little while. I'm going to turn these guys off and push this thing in. So one of the things you all probably haven't done a whole lot is, using the transform tools. So again, we can do scaling and things like that in here, but we're going to just kind of move this where we want it. So you'll notice when I come into this transform tool, it's kind of using center mass of my scan object here of where it was positioned based on where the scanner was. So this may or may not actually be on the part very well. if I pick my other part and go to it, you can see it kind of just throws it on, center masses where that was sitting. And that's probably just related to where they were on the actual turntable. So, but we need to line these things up a little bit. So what I'm going to do is I'm going to come in, rotate and translate, and we're going to go back to our, figure this out. We're going to use this part next. And I'm just going to get it randomly close to the part. So again, it's kind of hard to line things up like this, just because these axes aren't really how I would want to push it around. They're all at kind of obscure angles. So it's kind of hard to get things where I want it. It would take some finicky pushing around. So instead of really trying to get this thing to rotate, it's not rotating around the axis I want it to rotate around and stuff like that. So I'm just going to move it kind of close with that. And then what we're going to do is we're going to create some geometry and put like a little sub-coordinate system on here so we can manipulate this better. So let's come in and do that. So I'm going to just hide my main body for now, since we're not going to use it. And let's make some reference geometry to do this. So come in here and let's grab a couple things we know we're going to need. Like, I really want the center line vector of this hinge. So let's come in and grab that. I'm going to hit find cylinder axis. And I'm just going to use my box select and make sure I'm selecting through my data. We're just going to grab some of these ends that don't look too beat up. So that's pretty good. Again, we don't have to be super finicky, and with this thing we know is bent and a little bit messed up. So, and I got my preview axis in there where I want it, and we'll hit OK on that. And let's grab a couple planes. So I think I want to put it right in, I'm going to put it right in the middle of this just so it rotates about the center nice. So, and again, with this part, I'm going to be a little bit more finicky than I would be with this part, but I really want to kind of show everyone that, we want to use our tools so we can get things where we want them. So on something that's a little bit more exacting, I should say, we would spend this much time to do it, but on this part, it's a little overkill. So I'm going to come in and I'm going to find the center of these. So I'm going to grab two planes like out of there. And then what I'm going to do is I'm going to average these guys to find my center line. So there isn't really much else we could have used to do this besides those two planes. The ends have been, I don't know, this one looks like it's a little snapped off. That one's a little rounded. The outside of these things aren't really in great shape either. So let's find the center line by using that average. And what I want to do is I want to find directions so I can like put this in a direction I want it. So I'm thinking I'm going to use this as my up direction. So I could either use that plane, maybe I can use this back plane here. But let's pick some directions for this stuff. So let's come back into our planes here, grab my paintbrush, and I'm just going to grab something along this side here. We'll fit that in. And then I will fit something along the top here pretty well. Now this average plane in the middle I mean, it's average, but these things, we don't really know how straight they are. So, and I'd really wanted something that's perfectly perpendicular to that center line axis that I did, especially if I was doing a more critical part. So what I would generally do is come back into plane again, and I'm going to grab this plane and my vector. And we're going to say, that we need a point. That's right. We have to make a point where that plane is. So let's do that. So we grab my point here. I'll grab that plane and my vector for my intersection. And then what I'll do is I will make a plane based on my vector and that point. So now I have one that is perfectly perpendicular to that vector center line. You can see it's very different from what the average was. But we're going to keep that general center position and let it software tweak it from there. So now what I can do is I don't really need plane 1 and 2. we're not using. I'm going to turn off plane 5 since that's the one that's not straight. So, nope, 5 is. 3 is the one that's not straight. There we go. So, and then since I want to use directions on this, what I'm going to do is I'm going to pull out the axis that I want for directions. So we're going to use this centerline direction, and then we'll use this as one of my other directions. So since I want a direction, again, I could click on the plane, but I like making vectors just to keep myself organized. So let's pull that one out. So now I have a line, I have a point, I have like a centerline plane. I have my direction here. So let's grab some of that stuff out. So now that we have all this geometry that we want to use, again, I don't need that plane or that plane anymore. I think I'm going to use that vector, my centerline vector, and this other one here is my direction. So let's come in and make my subcoordinate system. So what I'm going to do is, instead of definition, I'm going to pick a point and 2 lines. So again, we have a lot of different ways we can make this. So I can do it from extractions of things and put it on, or I can come in and make geometry like I did. So again, we can do 3 planes, we can do some tangent stuff, some other fun things, but I can wrap my head around pick point and 2 lines pretty easily, which is kind of the hardest part here. And then we are going to do I'm going to pick my direction. So I want my first vector up. So I'm going to say what I want. I want like a Y and a Z. So let's do a Y and a Z. So let's put Y along the line here and then that being Z. So let's come in and pick my point first, and then I will pick my Y direction, and then vector 2 will be my Z direction. So, and to check that, it is putting it inside the mesh there, which is a little hard to see. So if I turn off the mesh, I can see what direction stuff is. Now I want to flip Z because I want that upwards. So just to make my life easier thinking about things. Doesn't matter, not really, because we're just going by moving it that direction. So, but that looks pretty good. So let's hit OK on that. So now essentially all this reference geometry I don't really need. So let's turn all that stuff off. Let's turn our other mesh back on and come in and align this guy up. So now that we have our coordinate system there, doing this alignment by transform is a little easier to pay attention to what we're doing and we have a greater ability of being able to manipulate it. So you'll notice rotate and translate, it still picks that center mass of the part. But what I'm going to do is hit use local coordinate, and then I'm going to pick the local coordinate. So now everything's lined up with our part. So as I yank stuff around and I twist it and everything else, it's going to move the way I want it to rotate about this center portion of the part. So we come into this. So now I have a better ability of saying, okay, I want to translate it along this direction. I want to rotate this thing down to where it should be, and I think it should be I want to try to match up the angle here with the back angle of this part. So you can look at it that way. If I twist it to get it in line, it's a little easier to twist it. So this side of the part looks better than the other side of the part, so I think I'm going to kind of try to visually line it up with this direction here. And poke at that a little bit. I'm going to pull this in a little bit, and then let's come up. So this side I can tell it stretched when it broke. So I'm actually going to leave that inserted into the part a little bit. And then I can roll this guy up a little. So this side lines up a bit. And this thing I did definitely leave some material on when it just snapped. So, but take a gander at that. And let's push this over a bit. and see how things look. So this is actually looking pretty good. Pretty well lined up with the side of my box there visually, which looks nice. And my twist looks pretty good for the top. Maybe we'll tweak it just a little bit more. So come in here and give it a little bit more twist. So, but that looks pretty good with where stuff should be. So, and it looks pretty flat to the bottom of this section, and the other side of the part, for instance, is kind of what I'm going for. The angle here on the back with these bump outs here looks pretty good too. I may give it a little bit more of a tweak down, just to visually kind of line that up. Again, we're going to model what we want, so we only really have to get this kind of close. Probably being finickier than I need to be at this point. So, but that looks pretty acceptable. So let's hit OK on that for getting our stuff lined up. And then now what I'm going to do is, because I really don't want to move this thing, I think it's good enough. I'm just going to lock these together. So I'm just going to come into my polygon tools here, hit combine, and just lock my meshes, create a single one. So we could leave them as two, and we could model things individually and then correct from there. If this was the more exacting part, I would probably do that. Leave them as two separate meshes, model this one out, model out the bulk of what I want in the other one, and then actually like transform the solids possibly to get stuff lined up exactly the way that I want it. But I think this is pretty close for what we're doing here off the cuff. So let's leave that go. I'm going to turn off my little reference coordinate system here, and let's put this thing on our real coordinate system now that we're lined up. So a part that this warped can be a little bit fun to do to get things to line up to where they want them. But since I lined this up pretty well with this side, and I'm saying the other side is kind of bent out, we're going to kind of use all the data from this side to check this out. So what I want to do to align this thing is, I think I'm going to pull out another plane here. And again, I'm going to use my handy dandy paintbrush. I could use like other selection methods, but I'm just going to pick the middle because God knows what's going on with that plane. So, okay on that. And to get this thing lined up, I think I'm actually going to do a sketch-based alignment. So I'm just going to kind of look at the bottom edge of this part here, or maybe the top edge too, and then I'm going to look at the direction that this thing is. So now we're going to find a way just to average the center of this. So if I really wanted to, I could probably come in here and extract these planes out again and average them to let it find the center line in between them. I don't know what's going on here. I don't know if that's like some chunk missing, but everything looks pretty deformed. So I think a sketch is going to be good enough. So it's one of my preferred methods to align things also, just because sometimes it's really handy when doing some more interesting things. So I'm going to come into mesh sketch on that plane. And the first thing I'm going to do is I'm just going to offset this down to get a direction off of the backside of this thing. So now that I have a line there, I want the other one. Now there isn't such a great way to do that, but there actually is a great way to do that. But there wouldn't be a good way to do that in one setup. So what I'm actually going to do is, and a lot of people don't really use this a whole lot, is I'm going to just add section command. So hit add section. Now we see we have offset section 2. Okay, and we can adjust them independently of each other. So I can actually pull this down onto the edge of my part here and create another set of cross sections just on the bottom. So now if we wanted to, we can use stuff to check for the other side. We can use it for extra data somewhere else. And if I really wanted to, I think I'm going to actually, we already have a nice outline of that box, believe it or not. So I think we're going to leave that there. But I'm going to pull it down here. And just because finding the outer edge of this is hard, I'm going to do a little silhouette here to get the outline of that data. So these we don't really need, but we're mostly just going to look at the outer inner edge of this thing. So I'm going to silhouette that in just to make sure I get the extent of it, and I have it boxed in. So I'm going to hit OK. Come into my sketch. If I turn my scan data off, So this is the line in question here that we're going to interrogate, and then like this one too, I think, on the outside, because this thing looks pretty bent. So maybe we won't use that one. Let's come into our line tool and lay a couple of these on. So, and yeah, we're going to use that. We're going to use a portion of this. So let's just come in and do something like this. So we'll hit OK. And just for fun, what I'm going to do is make these parallel to each other. So now as I adjust them, they're going to adjust together. So I can see if I move one, how well the other one keeps fitting. So let's pull this in a little bit. We'll pull this in a little bit. And you can see that we're moving them together here. So I'm just going to grab these things. They have to stay parallel, which you don't have a choice about. So, but as I move them, we can see like how close they are. So, so I did a pretty good job lining this thing up as far as to this section. It's not too far off anyway. And as I fit data in different spots, we'll see like how things change. So, but I think I like this. It's looking pretty good. Even if I bump this down, it stays pretty close. So I'm thinking that's a good scheme for alignment here. And I think I'm going to use these from this box here too. So I think I'm going to come in and I'm just going to grab some line section out of here. And we'll grab some of this section here. Notice it's just snapping where that pink polyline data is. Forgot, I'm going to put a line down the middle here, about down the middle anyway. And we'll do that. So let's come in and lock these things down. And now that they're locked down, let's go in and let's throw some symmetry on here. Get this thing in the middle. And there we go. Nice. So let's extend this guy out, and we're going to use this point for our coordinate system. So at this point, you guys kind of know how to do a coordinate system already. So we're just going to come in and like quickly do that. But I'm just going to use this point as my center, and then this is the direction, my plane as the top. So very simple alignment. We can turn this back on, come into our alignment. We will hit interactive alignment as we always do. Hit next. And for my position, again, I'm going to grab my center there. My z-axis, I'm going to pick as this top plane, and then my y-axis, or x-axis, I should say, I'm going to pick there. Let me flip the direction, so keep everything in the part. If I look on this side here, I can turn my front right top planes on, and if I click on my ISO view setting, I will see what my ISO view is. So honestly, that looks pretty good where it's at, lined up to my part. Actually, what did I pick? I grabbed something that I shouldn't have grabbed. So let's come in and helps if I grab the right directions. So, and my view, I'm updating here. So, I'm not moving it to the section. It's a common mistake that people get to. I forget to look every now and again. I want to move it to my origin. So let's actually move it to the origin. And what I'm going to do is I want to flip my direction here. So pick my position. Always helps if you specify where it's going before you try to put it there. So, and I'm just going to reselect everything here to make sure it goes where I want. So I live update the view, and now I have my ISO view. I got everything exactly where I want it. So we will hit OK on that. And now we're aligned with our coordinate system. So let me turn off my sketch here just to clear that out. So now we're lined up, we can just start drawing our part. So that kind of concludes putting things back together, getting them aligned. Of course, as we draw this thing, we're going to have to make some assumptions about how bent everything is and where it goes. But that's kind of how to put stuff back together in sort of an interesting yet challenging atmosphere.